Today we're going to look at solving compound inequalities. So a compound inequality is when we're going to have two inequalities joined together with either the word and or the word or. So here's an example with or. We have two inequalities and there's an or in between. Or we have two inequalities with and in between. So we can specify a little more. We have conjunctions, and conjunctions are the compound equalities that use the word and. So we'll see them like this occasionally with the actual word and in between, but more times than not, you will see it written as this. So this takes both of our inequalities and condenses it into what appears to be a single inequality. Okay, there's still two parts. We could still look at it and say x is greater than -2, which is this inequality. Or we can look at the right half of the inequality and that says x is less than 3, which was this inequality up here. So these both mean the exact same thing. They're just written a little differently. So we're going to have to solve these conjunctions. So here's one. 30 is less than or equal to 20 plus 5x less than or equal to 40. These, again, are going to be solved just like regular equations. So we have to do our addition and subtraction first. So we're going to subtract 20. This time we have to do it on the left side, in the middle, and on the right side. So when I subtract 20, I am left with 10 on the left, 5x in the middle, and then 20 on the right. And now I have to divide all three sides by 5. So that gives us 2 less than or equal to x, which is less than or equal to 4. Now, when we go to graph this, we're going to have two closed circles on both 2 and 4. And this says x is greater than or equal to 2, so we have to have an arrow to the right. This says x is less than or equal to 4, so an arrow to the left. Always make sure you read your inequality from the variable, from the letter. Read either to the right or read backwards to the left, but that will help you with your graph. Okay, here's another one, just a one step. We're going to divide everything by 2. So here we're not dividing by a negative. There is a negative over here, but we're only dividing by +2. So we have -9 is less than x, which is less than or equal to 7. And your graph would look like this. All of your conjunction graphs will have arrows that come together. Here's one more. Starts looking like this. Add 1 to both sides, or all three sides, and then divide by 3. Gives you 6 less than or equal to x less than or equal to 9. There's your graph. Both closed circles and your arrows point towards one another. So that's conjunction when you have an and in between. The other one is called a disjunction, and that's our compound inequalities that use the word or in between. So x is less than -10 or x is greater than 0. Here's another one, x is less than 5 or x is greater than 6. With disjunctions, they will always be written as two separate inequalities with the word or between them. You can't ever combine them. So here, when you go to solve these, you're just going to have to solve each of them individually. So on this left inequality, we're going to have to add 3 to both sides. And that leaves you with x is less than -2. On the right side, we're dividing by -2. Remember, when you divide by a negative, you have to flip your sign. So that becomes x is greater than 3. So when we go to graph these, we graph them individually. X is less than -2 is open circle to the left, and x is greater than 3 is an open circle to the right. One last example, here's another disjunction separated with an or. The left side we divide by -3, which switches our sign. So we have x is less than or equal to -4. The right side we're subtracting 10, so we get x is greater than 5. There is your graph. With disjunctions, your arrows will always point in the opposite directions.